Here we are in section 2.2 with exercises 19 through 28. Solve the inequalities and graph the solution. So solving is going to look this common three-step approach we've been using for all of the linear equations, except that we're going to switch whenever we multiply or divide by a negative. We also have compound inequalities, which means we're using the ors and or the ands. The or part of the answer can happen in either one or the other. And means it has to be in both to be part of the solution. We'll try to use a color coordination scheme with reds and blues and purples and whatever to make sure we understand that. So number 19, graph the solution. We also need to write the answer in set and interval notation. All right, so here we're going to have the blue x greater than or equal to 8. So let's put 8 right here. I'm going to put this above the number line so that we can see what happens when it crosses or how it uses a compound. So there's our or statement. Our x greater than or equal to 8. We used equal to 8, so we used the bracket like a closed dot. And then on the other one, x less than -1. So -1's right here, and it's going to be open parenthesis going down this way. So the or statement is the answer could either be here or here, which means we just put them in like they are. So there we go. The solution set then looks like x such that x is greater than or equal to 8, or x is less than -1. And we can't get any more simple than that. So that is the set notation of the answer. And the interval notation would then look like this: from -infinity to -1, and from 8 all the way up to infinity, but a closed one there. And then this u is for union, same as or. So there's set, there's interval, and there's the graph right there. The black is the final answer. All right, let's look at the next one. Number 20. 4x minus 5 is greater than or equal to 7. If we solve this, let's go ahead and put it right down here. 4x greater than or equal to 12 if you add 5 to both sides, and then x is greater than or equal to 3. And we have an and in there. That's going to be important, but let's do the red right down here. 4x less than or equal to 20. So that is x is less than or equal to 5. So let's put those on the graph, and then we'll do the and in just a minute. So let's mark 0. That's important. Then we'll mark this one, x is greater than or equal to 3. So if here is 3, and we're going greater than or equal to it, so that will look like this. All right, now the red one, x is less than or equal to 5. So say 5 is right there, and 5 goes like this, all the way down here. Ooh, got a little bit off. There we go, and squiggles that way. So you'll notice that we've got to use and. Red and blue make purple. So in this case, the things that are purple are from 3 to 5. Can you see how both of those are in? Those answers are the ones that are in both of them. So that's what it means, both, over here. So the answer then, we can simplify it down just a little bit, and we can write it like this: the set of all x such that x is sandwiched in between 5 and 3. Greater than or equal to 3, less than or equal to 5. Good. There's the set. And now the interval is from 3 to 5. And it's closed on both of them, like that. Excellent. Number 21. X is less than or equal to 5. Let's put that guy on. Here's 5. And we're going to go less than or equal to 5. It's down that way. Then x is less than 9. So there's 9, and we're going to go less than. So a parentheses there and go this way. So this is an or statement. So we need to color all numbers that are either colored blue or red or both, which in reality turns out to be just from 9 down. See how this one is kind of irrelevant. If you're less than 5, then you're already less than 9. So all of these numbers are colored there. So to simplify that, it becomes the set of all x such that x is less than 9. And it's from -infinity to 9. This is interval notation, and the black is the graph down there. All right, the and statement on number 22. X is less than or equal to 5, so here's 5. And we're going to go less than or equal to. Good. And then we have x less than 9. Hey, look, these are like almost going to be the same thing. So here's 9. And we go less than 9, so we have a parentheses there, open circle at 9. And then and, however, remember what and is. And means purple. So what are all the numbers that are colored purple? Well, certainly all of these guys are colored purple right up until 5. And that's it from 5 down. So an and statement turns out to be the set of all x such that x is just less than or equal to 5. So again, yeah, these fit in both categories. These ones right here, 7, 8, 6, they are just in one of them, so they are not in both. And means both. So it's interesting that on an or statement, you kind of take the bigger of the two if they're headed the same direction, and on an and statement, you take the smaller of them. So this would be from negative infinity, which we never hit, up to 5, which we do hit, and so we use that symbol, set, interval, and graph. Great. Number 23. 7x minus 2 is less than or equal to 1, so add 2 to both sides, and we get 7x less than or equal to 3. Divide by 7, we get x is less than or equal to 3/7. 3/7. I wrote a 3 up there. So 3/7, put it right there. 3/7, and we want to be less than or equal to. There we go. We use the bracket for equal to. I guess I should put it right over top of that guy. All right. Or 5x. Let's use red on this guy. 5x greater than 25. That's x is greater than 5. So here's 5 up here, and we want to go greater than, like this. The word or, we include anything which is in either one of them. So the answer is all of these guys right here combined with all of that up there. So we have the set of all x such that x is less than or equal to 3/7, or x is greater than 5. No simpler way to write it. And interval notation is from negative infinity to 3/7 with a bracket. Union, that's that u again, 5 to infinity. Good deal. Jump over to number 24. Here we have 3x plus 6 is greater than or equal to negative 7. So that is 3x greater than, not greater than or equal to, just greater than negative 13. Divide by 3, and we have x greater than negative 13/3. So there's negative 13/3. And we are going this direction. Okay, with parentheses right there. And then the second one, yeah, that guy, that's going to be 2x less than or equal to 11. So x less than or equal to 11 halves. So here's 11 halves somewhere up here. And it looks like we are going less than 11 halves, but we are equal to it. So it's going to look like this. And the word in between them is and. So we've got to find the red and the blue at the same time, which is red and blue make purple. So that is from here all the way up to here. So the purple is the graph of the solution. Come right down there. Oh, good. So this is, we can write it as x less than or equal to 11 halves greater than negative 13/3, and then put the nice looking stuff around it. Good. That's set notation. Interval notation would be from negative 13/3 open up to 11 halves with a closed circle like that. So we have the set and the interval and the graph. Excellent. Great. Number 25. 4 is greater than negative 2 minus 7x. So add 2 to both sides and we get 6 greater than negative 7x. So divide by negative 7. Oh, look at that. If we divide by a negative, we switch it. Remember, that is x is bigger than 6 divided by a negative 7. So negative 6/7. Ooh, pay attention to that. We did a switcheroo here because we divided by a negative 7. That's important. So x is greater than negative 6/7. So if here's negative 6/7, we're greater than, notice that x is on the large side. So this is greater than. It's going to look like that and go that direction. All right, the other of this compound inequality, 2x greater than or equal to 4 minus 4x. Let's add 4x to both sides. We get 6x greater than or equal to 4. Divide both sides by 6. We get x greater than or equal to 4/6, which is equal to 2/3. So we have 2/3 here, and we are greater than or equal to it. So that's going to go with a bracket and this direction. And what is the word between them? The word between them is or. This is an or statement, so we need to take everything that is in either this one or that one. So we're going to start down here at -6/7 like that. And yeah, I color everything that is either red or blue or both. So the answer is just those that are greater than -6/7. So set will look like this: x greater than -6/7. This turns out to be useless because we already have all of them. And then interval notation is from -6/7 all the way up to infinity. And a parenthesis saying it is open right there. We don't quite hit -6/7. Good deal. Number 26 here. Oh, this is a compound inequality where we have -5 is less than or equal to -3 plus 2x less than or equal to 19. This compound inequality is written with an and they just stuck them both together. All right, so add 3 here, add 3 there, add 3 there. That will maintain the inequality in both places. So this is -2 less than or equal to 2x less than or equal to 22. Now divide everything by 2. Notice we are not switching direction because we're not dividing by a negative. So this is x is less than or equal to 11 greater than or equal to -1. I like that. That's pretty nice. We have a -1 there and we have an 11 there. And we are x is bigger than -1 and smaller than 11 at the same time. And we don't even have to use the red and the blue and make purple. It just says it's sandwiched in there. So there's our set notation, our graph, and our interval notation. -1 up to 11, that interval. Excellent. And number 27. Here we have a compound inequality. This is an and, so we could just write it down. 7 less than 5 minus 3x less than 17. Subtract 5 from all three places. This maintains the inequality, so we get 2 less than -3x less than 12. Divide by -3. Now pay attention to what we just did. We just divided by a negative number. That must switch the direction. So this is -2/3 greater than x greater than -4. So if here's -2/3 and here's -4, yeah, all the x's, the solutions are sandwiched in between those like this. And this is an and statement. This is taking x bigger than -4, which would go this way, and x less than -2/3, which would go that way, and saying and. So it's a fancy way of sandwiching them right in between those. I like that. So this we can just write as the set notation. And then the interval notation goes from -4, always start from the left point, up to -2/3. Both of them are in parentheses. Good. And number 28. 2x plus 5 is greater than 7. So subtract 5 from both sides. We have 2x greater than 2. Divide by 2, we have x greater than 1. So we have a 1 here, and we're going to go greater than 1 up that direction. It says x is less than or equal to 15. So if 15 is right up here, less than or equal to will be a bracket and comes down here like that. All right, and the word in the middle, the conjunction between them, is that it is an and. So we have to find all the points that are in both of them. So we have from 15 all the way down to 1, and we can write it in that shorthand that x is less than or equal to 15, greater than 1, and that's our set notation. And our interval notation is from 1 to 15. Open on 1, we don't hit it, and closed on 15, we are equal to it. Excellent.